Hello friends, in this operating system class we will see the disk scheduling, and this is one of the important topic from 4th unit, and in this class we will see why disk scheduling algorithms are important and the important terms which are used to compute the disk scheduling and the different disk scheduling algorithms: first come first serve, shortest seek time first, scan, CSCAN, look and CLOOK. We will see all those things one by one in today's class. Why disk scheduling algorithms are important? Okay, the disk scheduling algorithms are otherwise called as IO scheduling algorithms, which is done by operating system to schedule IO request arriving from process for disk data. Okay, see here we are having three different processes and these will give request for the data which is available in the hard disk, right? Here multiple IO requests may arrive by different processes and only one IO request can be served at a time by the disk controller. Okay, disk controller is available here. Disk controllers are available here. So the disk controller will select any one of the process which is available in the wait queue. Okay, that is request queue. IO request will wait in this request queue. Okay, here we are having three processes. All the processes give the IO request and those requests will be wait in the request queue. Okay, and this disk controller will select any one of the request. Okay, and the other request need to wait in the waiting queue and that need to be scheduled. So based on the scheduling algorithm, the disk controller will select any one of the request and the corresponding data will be served from the disk data. Okay, suppose two or more requests may be far from each other, that is one data may be here and another data may be here. Okay, those are very far distance and the result is greater arm movement, disk arm movement. Okay, arm should move very long distance, so this will take some time, isn't it? Okay, now hard drives are one of the slowest part of the computer system. See, when compared to CPU or main memory, the disk is very slow. Okay, but the CPU and main memory are very fast devices. Now the hard drives are very slowest part of computer system and thus needs to be accessed in efficient manner. So efficiently we need to select the request from the process and the corresponding request will be accessed by the disk controller and data will be retrieved from the disk. For this disk scheduling algorithms, we need to compute the seek time, rotational latency, transfer time and disk access time. Let us see these things one by one. The first one is seek time, that is the time taken to locate the disk arm to specified track, okay, where the data is to be read or write. This is called as seek time. So we have to move this read write head to the corresponding place where the data is actually stored in the disk. Okay, that is called as seek time. So the disk scheduling algorithm that gives minimum average seek time is better. Okay, the average seek time should be reduced. And second one is rotational latency. This is nothing but the time taken by desired sector of disk to rotate into the position. Suppose if the sector is here, the disk should be rotated towards the read write arm, read write head, isn't it? Then only the data will be read or write. So the disk should scheduling algorithm that gives minimum rotational latency. The rotational latency should be minimum. Then the transfer time. Transfer time means data transfer time means from IO device to computer. Okay, that is data transfer time. It depends on the rotating speed of disk and number of bytes to be transferred. Okay, if the speed is high, then data time will also be reduced. If the number of bytes are reduced, that is minimum data to be transferred means the transfer time should also be reduced. Okay, this is depending on the rotating speed as well as number of data to be transferred. And the last one is disk access time. Disk access time is the sum of all these three things, that is seek time plus rotational latency plus transfer time. Okay, the sum of all these things will form the disk access time. First come first serve disk scheduling algorithm. This is very simplest and straightforward disk scheduling algorithm. Here the requests are addressed in the order they arrive in the disk queue. This is first come, that is the request which come first will serve first. Okay, let us see one example for this. The order of queue request is this one, that is 82, 170, 43, 140, 24, 16 and 190, and the current position of read write head is at 50. Okay, let us take the disk scan from 0 to 199. Okay, total 200 tracks are there, and the current position of read write head is at 50. This is the current position. Now the first request is 82. Okay, so now the read write head should move to 82. Okay, 50 to 82, and we need to collect this data from here. After that the request the data is available in the position 170. Now the read write head should move from 82 to 170. After that 43, hence the data should move from 70 to 43. Okay, this will take some time, isn't it? For each and every read write head movement should take some time. See, after that the data is available at the position 140, isn't it? Now the read write head should move from 43 to 140. After that 24. Okay, 24 is here. 24 is here, then 16 is here, after that 190 is here. Okay, so in first come first serve scheduling algorithm, the read write head movement is like this. Okay, like zigzag movement. From this now we have to compute the seek time. Okay, first the current position is at 50. For first movement the data is available in the position 82, hence the read write head should move from 50 to 82. So what is the movement here? 82 minus 52, that is the movement. Okay, that much distance the read write head will be moved. And next one is, see, from 82 the read write head should move up to 170, isn't it? So the distance is 170 minus 82. So we have to take the largest number first and smallest number next. After that from 170 the read write head should move up to 43. Okay, the movement is 170 minus 43. So after that 43 to 140 that should move, so 140 minus 43. Now 140 to 24 the read write head should move, isn't it? So 140 minus 24, after that 24 minus 16, see 16 is here, after that 16 to 190 it should move, so 16 to 190. So the total movement is 642. The total read write movement is 642, so it will take the seek time is 642. The advantage of first come first serve scheduling algorithm, here every request gets a fair chance for getting services and no indefinite postponement, that is all the requests which are available in the queue will get serviced. Okay, and when come to disadvantage, it does not provide optimized seek time, because the seek time in FCFS is very high, that is very slow service it will provide, and it may not provide best possible services, right? SSTF, that is shortest seek time first scheduling algorithm. Here the request having shortest seek time are executed first. Okay, here the seek time of every request is calculated in advance, which are waiting in the request queue. Okay, and according to the seek time, the requests are scheduled accordingly. Here, the request near the disk arm will get executed first. Okay, this is the importance of shortest seek time first scheduling algorithm. Okay, and this is the advancement of FCFS, and it of course decreases the average seek time, that is average response time, and increase the throughput of the system. And let us take the same example for explaining the shortest seek time first scheduling algorithm. These are the requests which are available in the request queue, and the current read position is 50. The head is currently available in 50. So from 50 we need to identify which are shortest seek time. See, from nearby 50 we are having 43 and 82, this side 82, here 43. So when compared to these two things, 43 is the shortest distance, isn't it? So the controller will select only the 43. So from 43, of course 24 is the shortest one. So 24 will be selected next for execution. After that 16. Okay, from 16 the shortest one is only 82. Okay, from 16 to 82 the head will move and to request the data. After that from 80 to 140 is the C140, and after that 170 is there. Then the controller will select 140 and 170. After that 190. Okay, finally the 190 will be selected and executed. Now we have to compute the seek time. Okay, 50 minus 43, 50 minus 43, then 43 minus 24 and 24 minus 16. Next 82 is here, 82 minus 16, and next one is 140, 140 minus 82, next 170, 170 minus 140, after that 190 is there, 190 minus 70. So the final seek time is 208. See, when compared to first come first scheduling algorithm, first serve scheduling algorithm, the shortest seek time first algorithm will give the better result. The advantages and disadvantages of SSTF algorithm. The advantage, average response time will be very much decreased when compared to first come first serve scheduling algorithm, and throughput of course increased. So these two are very big advantage of this particular algorithm. When come to disadvantage, the overhead to calculate the seek time in advance. So before giving response to the request, we need to compute the seek time for all the responses which are available in the request queue, isn't it? So this is a very big overhead, and it can cause starvation for the request which is higher seek time. Suppose if the seek time is very high, for example 190, 199, and all the previous are very less, then it request this particular request have to wait very long time, the starvation may occur. Okay, and high variance of response time, and this particular algorithm will favor only the request which are shortest seek time. The next one is SCAN scheduling algorithm. The SCAN algorithm is otherwise called as elevator algorithm. Okay, why? Because the disk arm starts at one end of the disk. Okay, for example that will starts at one end of the disk, and this moves towards the other end of the disk. So it will continuously move only towards the other end of the disk, and once it reaches the other end, then only it will come back to the previous end of the disk. Okay, so the service request until gets to other end of the disk, where the head movement is reversed and servicing continues. So all the services will be taken only first from forward direction, and then only it will take the request from reverse direction. So this is called as scan. So it will completely scan the disk from one direction to another direction like this. Let us take the same example for explaining this scan. Okay, these are the request waiting in the request queue and the current read write head position is at 50, and here the disk arm should move towards the largest value. That means from 50 it will start the largest value from 50. Okay, which is the largest value from 50? 82, isn't it? So from 50 it will move to 82. After that, from 82, which is the next largest value, that is 140, isn't it? So that will move to 140. After that 170, then 190. Okay, it will go like this. Then after 190, here it will go to the other end, which is the other end 199, isn't it? So 192 it will move to the last end 199, then only it will be reversed. In between, the read write head cannot be reversed. So this is called as scan. Okay, now we have to compute the seek time. Very easy to compute. From 50 it will go to up 199, isn't it? So 199 minus 50 plus, from 199 it will go back to 16, isn't it? So 199 minus 60. So what is the seek time? 332 is the seek time. The advantage of scan: the throughput is very high, okay, and low variance of response time. This is another advantage, and the average response time will be very much reduced. So these are advantages. When come to drawback: long waiting time for request for the locations just visited by disk arm. For example, the current location is here, that will move forward. Suppose this particular request have to wait until it reach to the end, then it has to come back towards this particular location. Okay, so the long waiting time for the request for locations just visited by the disk arm, this is the drawback. The next one is CSCAN. CSCAN is almost similar to scan, that is the head, that is read write head, move from one end of the disk to another end of the disk, and the services are, the request are serviced. Okay, so this is the starting point of the disk and this is the ending point of the disk. The head will move from current position to the increased order, and that will reach to the other end. So in between request will be serviced. Okay, once it reaches the other end, immediately it returns to the beginning of the disk without any service. So immediately it returns to the beginning of the service, then only the services will be taken place for requesters will be serviced. Okay, this is called as CSCAN. Let us take the same example for explaining CSCAN also. These are the request waiting in the request queue to get service, and the current read write head is at 50. Okay, this is the 50, and the service, that is disk arm, should move towards the largest value. So from the 50 the disk arm will move up to 199. This is the other end of the disk. Okay, when returning this disk arm, it will not do any services. Okay, this directly come to 0. After that, only in the largest value, that is increasing order, it will do the service. Okay, now let us compute the seek time, that is 199 minus 50. So 199 is here, that is the other end, current position is 50 initially. Okay, so 199 minus 50 plus 199 minus 0, because in the returning it does not do any services, isn't it? So we need to compute that distance also. 199 minus 0, that is 199, and plus 43, 0 to 43. Okay, so the total is 391. So the advantage of CSCAN is it provides more uniform waiting time for all the responses when compared to the scan. This is the advantage of CSCAN. The next one is CLOOK. LOOK is similar to SCAN, but except the disk arm will goes only to the last request to be served. It will not reach the end of this disk. Okay, and from here this will reverse the direction, right? And the advantage of this is the extra delay will be very much reduced due to unnecessary traversal to the end of the disk. Okay. Let us take the same example. So these are the requests waiting in the request queue, and the current read write head is at 50. Okay, this is the current position of read write head, and the service should be taken place towards the larger value from the 50, which is the larger value 82. Okay, it will move in this direction. Okay, so the read write head will reach up to 190. It will not reach 199 like SCAN, isn't it? If it moves to 199, then this will be SCAN. So the advantage of LOOK is it will reach only to the last request. Okay, from here the head will reverse its direction. Okay. Now let us calculate the seek time. So the seek time is 190 minus 50. So this starts from 50 and it will reach up to 190. Okay. So 190 minus 50 plus 190 minus 16. Okay. So this is 314. The next one is CLOOK. CLOOK is similar to CSCAN, but here the disk arm goes only to the last request to be served. Okay, from 52 it will go up to 190. Okay, and the disk arm goes to other end of the least request. So 192 it will move to 16, not to 0. Okay, so it prevent the extra delay which occurred in CSCAN. Here also we can use the same example. These are the requests which are waiting in the request queue, and current arm position is 50. So from 50 we can start towards the largest value. The largest value is 190. So from 190 the read write head will reach 16 once, that is 16. Then only it will serve towards the larger value. Okay. Now let us calculate the seek time. See, seek time is 190 minus 50. See, 190 is here, 50 is here. Okay. So the time taken to travel between 50 to 190. After that 190 to 16. Okay, 190 to 16, and next 43 minus 16. Okay, the time is 341. Up to this we have seen the importance of disk scheduling algorithm and some of the terms which are used in disk scheduling algorithms. Then the different scheduling algorithms like first come first serve and shortest seek time first, SCAN, CSCAN, LOOK and CLOOK. Okay. And in the next class we will see another important topic from 4th unit. Thank you.